Hello everyone! Our topic for today in Science-7 Quarter 4 Week 3 is about solar energy in the layers of the atmosphere. Lesson number 1: Solar energy in the atmosphere. This is the brief introduction. The Earth is completely surrounded by a sea of air known as the atmosphere. The pull of Earth keeps this sea of air close of the Earth. Without the atmosphere, life cannot exist on Earth, for the atmosphere contains oxygen, the life-sustaining gas. From the air, plants get carbon dioxide needed in order to live. The layer of air also protects us from the intense radiation by day too much loss of heat by night. Air is a mixture of many gases. For example, another brief introduction. Average composition of atmosphere. Substances. Nitrogen. The percentage by volume of nitrogen at sea level is 78.3 and about 9 kilometers up, 79.2. At oxygen, the percentage by volume at sea level is 20.99 and about 9 kilometers up is 7.0. In argon, the percentage by volume at sea level is 0.93 and about 9 kilometers up is 0.03. Carbon dioxide percentage by volume at sea level is 0.03. In hydrogen, the percentage by volume at sea level is 0.01 and about 9 kilometers up is 13.6. Neon, percentage by volume at sea level is 0.00123 and about 9 kilometers up is none. Helium, percentage by volume at sea level is 0.0004 and about 9 kilometers up is 0.126. Krypton, percentage by volume at sea level of krypton is 0.00005. Xenon, percentage by volume at sea level is 0.006. Radon, percentage by the volume at sea level is trace. Water vapor, percentage by volume at sea level of water vapor is 0 to 4%. What information do we learn from the third column? Answer. First, we learn that there is a very little oxygen high up in the atmosphere. Note, this is the reason why hikers experience difficulty in breathing when they climb high mountains. What information do we learn from the third column? The answer is, secondly, we learn that the composition of air is not uniform throughout the atmosphere. What if the concentration of carbon dioxide and nitrogen were reversed? The answer is, the 0.3% concentration of carbon dioxide is sufficient to keep the earth warm and permits life exist. Increasing its concentration to 78% will greatly increase Earth's temperature. Although water vapor and carbon dioxide make a very small amount of the gases in the Earth's atmosphere, they are very important because of their ability to absorb. These gases not only produce important weather features such as cloud and rain, but also have considerable influence on the overall climate of the Earth through the greenhouse effect and global warming. How is Earth's atmosphere structured? Earth's atmosphere is relatively thin, extending up to at least 500 kilometers, 300 miles above the planet's surface. The atmosphere is structured in different layers according mainly to vibrations in temperature. Layers of Earth's atmosphere: exosphere, thermosphere, mesosphere, stratosphere, troposphere. How does temperature vary in the atmosphere? Exosphere is equals to 1,200 degrees Celsius to 2,000 degrees Celsius. In thermosphere is equals to 86.5 degrees Celsius to 1,200 degrees Celsius. Mesosphere equals to negative 2.5 degrees Celsius to negative 85 degrees Celsius. Stratosphere is equals to negative 56.5 degrees Celsius to negative 2.5 degrees Celsius. Troposphere is equals to negative 15 degrees Celsius to negative 56.5 degrees Celsius. Layers of the atmosphere. Solar radiation passes through Earth's atmosphere and heats up the planet's surface. The oceans end up absorb approximately half of this incoming solar radiation, while a small fraction is emitted back into the atmosphere as infrared radiation. The heat absorbed by the Earth's surface is then transferred directly from the land or the water or the cooler air closest to the surface through conduction. The direct spread of heat from one substance to another. Once heated, this air becomes less dense or lighter and rises through a process called convection. As the air rises, it expands and discharges its heat as it flows upward through the troposphere. After the heat is discharged and the air cools, it becomes denser and begins to sink. Consequently, the troposphere is generally warmest near Earth's surface and coolest at its highest point. Layers of atmosphere. Stratosphere, ozone layer. Stratosphere. The next layer, known as the stratosphere, extends from the troposphere upward to approximately 50 kilometers above Earth's surface. In the stratosphere, temperature rises with the increasing altitude. The absorption of UV radiation in the ozone layer that is found in the stratosphere causes temperature to increase. UV absorption is greatest at uppermost level of the stratosphere. Hence, air temperature is also highest in this region. The post at the top of the stratosphere is the stratopause. Mesosphere. Above the stratosphere lies the mesosphere, which stretches to approximately 90 kilometers above the surface of the Earth. In the mesosphere, temperature begins to decrease again. The mesosphere's lower temperature results in part from the low concentration of ozone, so little solar radiation is absorbed in this layer. The mesosphere is dark, with air pressure so low that a human could not survive in this layer. For example of mesosphere, a meteor. Thermosphere. The thermosphere lies above the mesosphere and extends approximately 600 kilometers beyond Earth's surface. Temperature begins to increase again in the thermosphere. The increase in temperature or inversion is due in part to the absorption of UV and X-ray radiation and the impact of the solar wind a continuous stream of protons and electrons given off by the sun. Space shuttles fly in this area, and it is also where the auroras are found. Exosphere. The exosphere represents the outermost layer of the Earth's atmosphere. It extends from the top of the Earth's thermosphere to 10,000 kilometers above Earth's surface. In this layer, atoms and molecules escape into space, and higher altitude satellites orbit our planet. Almost all of our energy available at Earth's surface comes from the sun. Example of exosphere. What is the greenhouse effect? Greenhouses allow sunlight to enter but prevent heat from escaping. The transparent covering of the greenhouse allows visible light to enter without obstruction. It warms the inside of the greenhouse as energy is absorbed by the plants, soil, and other things in the building. Air warmed by the heat inside, it retained in the building by the roof and wall. The transparent covering also prevents the heat from leaving by reflection and energy back into the walls and preventing outside winds from carrying it away. In a greenhouse, the glass lets light go in but traps in heat energy, raising temps. For example, the Earth's atmosphere is compared to a greenhouse besides nitrogen and oxygen. Earth's atmosphere contains trace gases such as carbon dioxide, water vapor, methane, and ozone like the glass in the greenhouse. The trace gases have a similar effect on the sun's rays. They allow sunlight to pass through, resulting in the warming up of the Earth's surface, but they absorb the energy coming from the Earth's surface, keeping the Earth's temperature suitable for life on Earth. This process is called greenhouse effect, and the trace gases are referred to as greenhouse gases. Enhanced greenhouse effect. When people burn more and more organic matter, the amount of carbon dioxide in the air increases dramatically, and to it the fact that there are other greenhouse gases aside from carbon dioxide and water vapor. This includes methane, nitrogen oxide, and CFCs. The result may be unusual increase in temperature. This is known as enhanced greenhouse effect. Enhanced greenhouse effect can contribute much to global warming, and prolonged will bring about climate change. The world is now experiencing various consequences of global warming and climate change, such as rising sea level, floods, droughts, heat waves, and wildfires. And that would be all in Science-7 Quarter for Week 3 about solar energy and the atmosphere. Thank you for watching. Until next time, goodbye!